All right, this problem asks us to take a look at the three states of matter and to draw a particular level representation of those three states. So drawing a diagram helps us understand whether or not we've mastered the concept. And so if I take the three different levels of matter, the three different states of matter, and I want to draw three different pictures representing those three states, then I need a container to put them in. And so I'm going to use just little circular containers. And you'll see why I chose a circular container here in just a second, because it'll help me depict the properties of these three states pretty accurately. Okay, and so I know that it's solid, liquid, and gas. Those are the three states of matter. So in order to depict their properties correctly at a particulate level, we're going to use these three diagrams. Now, particulate level means use a dot or some other representation of a particle. So for a solid, remember that the particles are very close together. They also maintain their shape. So the reason why I picked a circular container is that I could clearly show the particles retaining their shape in the container. So I'm going to draw it in roughly a shape of a square. I'm going to draw the little particles, and I'm not going to leave too much space in between them to illustrate that they're very close together. The particles are close together. Okay, now what's the difference between a solid and a liquid? Well, the particles are still very close together, but the particles of a liquid are allowed to move around each other, and because they can move around each other, they take the shape of their container. So in order to show that, I'm going to still draw the particles very close together, but instead of being a cube, which doesn't conform to the shape of the container, I'm going to show a liquid with the particles close together, but still very much spread out along the bottom of the surface of the container to illustrate that it's taking the shape of the circle. So this is a liquid representation. All right, what about gas? So the difference between solid and liquid are just about the particles being able to move around each other, which leads to the fact that liquids can take the shape of their containers. But by and large, the particles are essentially as close together in the solid and the liquid on this scale. When we talk about a gas, there's huge distances between the particles. So if I were going to accurately draw a picture of a gas, I'd want to make sure that the particles are nowhere near each other. Now, I would also want them to sort of evenly spread out and take the shape of the container as well. And the last thing that I would want to do is to show the reader that not only do the gas particles evenly spread out, not only are they far apart, they take the shape of the container, but they're in constant motion. So I might want to go ahead and make some sort of trails or something to kind of give me an idea that they're in random motion, going all sorts of different directions. And I might even want to say something like, oh, this one, it bounced off the container. That the collision with the container was elastic, but it's harder to see that particular property with this diagram. The important part of the diagram is that for gases is they're far apart, they can move around each other, so that means they take the shape of the container, they fill out the container completely, and that they're in constant motion. And so and the motion is in random directions. And the other part of the motion is that it's in straight lines. And so the particle doesn't change direction unless it hits something and hits a container. And so that's what we're showing here with these lines. Okay, that's it.